Hi, and welcome to One Proportional Hypothesis Testing. What I thought we would do is start up with a quick warm-up question dealing with tossing a coin. Don't worry about the music theme, it's going to come in handy on our last example today. So notice the parameter has already been defined. P is the true proportion of times the coin lands on its heads. You're going to construct and interpret a 95% confidence interval for a sample statistic given below. Pause the video here and try to answer this question on your own, and then hit play to see how well you did. Hi, here is your answer for you. So notice your p hat is the 595, z-score is 1.96, n is the number of times, which is 220 tosses, broken down to your margin of error, and finally your interval. What I really want you to pay attention to and really think about this interval is we're really saying that I'm 95% confident that the true proportion of times the coin lands on its head is between 52.7 and 66.3%. Interesting, because if a coin is fair, how often should we expect it to land on its heads? And furthermore, what number is not in that interval? Interesting. Welcome to One Proportional Hypothesis Test. This is how we're actually going to determine if an outcome is within reason, or is it something that is, in fact, statistically significant enough to suspect something is going on. So here's the basis of inference. Am I actually surprised? Basically, should I be rejecting the null if I am in fact surprised? How surprised am I? Well, what's the p-value? Shows how surprised I should be. The last one is, well, what would not surprise me? What can I expect, or what would be within reason? And that's when we would build a confidence interval. If you do not know how to build a confidence interval, I recommend doing that before learning hypothesis testing. All right. So a couple things I want to quick refresh is if you have a high p-value, that means you have failed to give convincing evidence against the null because what you just saw is actually likely to occur. Basically drawing 2 red cards in a row. 25% chance, yeah, it's a little bit funky, but really not enough to suspect something's off about the deck. However, if you have a low p-value, that means ho must go. Evidence is against the null is very strong because it is unlikely to actually occur. And that's when it becomes statistically significant, like drawing 7 red cards in a row. You might want to turn over that deck and make sure it's actually half and half. Usually 0.05 is our cutoff value. Steps for hypothesis testing. I usually use these 6 because I think it breaks it down really well. State that parameter. And are you estimating the true proportion of coins that land on heads? The true average gas mileage for a vehicle, anything along those lines. Go ahead and state your null and your alternative. Make sure to use parameter notation, no sample crap. You can either name your method or use the formula. I like to do both because I think it makes things a little bit clearer, but you're more than welcome to pick one over the other. Please, oh my, check those darn conditions. I know they're a pain in your, well, you guessed it, booty, but they're definitely worth doing because here's the problem. Steps 5 and 6 don't really matter if your conditions have failed. Find that darn p-value and eventually state your conclusion with that sexy context. Always give it a little bit of zest at the end. Don't just fail to reject no ho without putting the ho in context. And again, quick little recaps. Feel free to pause the video to write those down. All right, tossing that out, let's go ahead and check out our first example dealing with my personal favorite, M&Ms. It all comes down to candy. So here's the thing. Let's suppose that 20% are orange M&Ms. Let's say you have randomly selected a bag, found 21 orange ones out of 122. Okay, so does this contradict the company's 20% claim? Should I be concerned? Is my bag unusual or is it just funky? So P, true proportion of orange M&Ms. You can even say actual proportion of M&Ms. Conditions, notice it does say a randomly selected bag. So stated, my personal favorite. Approximately normal. This condition tends to be a little awkward because a lot of people use the wrong P there, especially because you start to get to a lot of P's. Because you're assuming the claim is true, make sure the P that you're using is 20%. Don't use the sample statistic. And luckily for us, the population of M&Ms is quite high. Null hopefully is proportion is 20%. Nothing's fishy going on. The company is amazing. They're truth tellers, whatnot. My personal favorite is always the alternative. It is not 20%. There is something funky and fresh going on here, and I'm going to find it. The show part is where you can do all of your mechanics. And I love to organize all those numbers into nice little notations. So N, sample size, 122 M&Ms. The number that I found were orange were 21. My p hat was about 17%. Here's the problem. You could probably stop right there and go, whoa, whoa, whoa. That company are liars because I found 17% and they're claiming 20. Here's where hypothesis tests will help you out. It's going to show you if what you have is truly unusual to go to the company and yell in their faces, or is it within reason? So why not build a z-score? Let's see how far from the average it actually is. Well, I expect it to be around 20%, but mine was 17. So notice below average, negative z-score. Let's go ahead and calculate that p-value. Go to normal CDF. Notice you have negative infinity up to that z-score. Here's the problem. If I do that, I get 22. Well, go back to your alternative. Notice your alternative doesn't say that it's just less than 20%. It says not equal to. So it is possible that maybe it is at the other end of the tail. So really make sure to multiply by 2. And I know that part seems a little confusing, so here's what I'm going to do for you. Show you a quick little sketch. And I think hopefully that'll help you kind of understand the two tails that it's not equal to. Not too terrible. There's your p-value. Wow, looky there, 44%. That basically is really not that unusual. It almost seems like that could occur almost 50% of the time. So, final tell statement. Our p-value of 0.44 is definitely more than the 0.05 cutoff, so we have to fail to reject. I've not quite found enough evidence to suggest the proportion of orange M&Ms differs from the advertised 20%. That is the entire mechanics. Notice I do understand this takes a while. Boy, wouldn't it be great if the calculator had a feature that let us do this a little faster? Oh, yes, there is. Let's do the same problem with a couple calculator steps. So here's what you're going to do. You're going to hit the Stat button on your TI-83 or 84 calculator. Go all the way over till you see Test. You're going to choose option numero 5, one proportional Z test. Again, that is Stat on a TI-83, 84 calculator, all the way over to Test, option number 5. Punch in all the information you have. Notice P0, it would be the null, 20%. X is the number you found, well, 21, number sample size, 122 M&Ms. I want to know that if the proportion is not equal to that 0.2. And you've got two features here, calculate and draw. I love both of them. Let's look at calculate first. And I want you to gaze at the glory that is this calculator. Notice it states the alternative at the top, proportion not equal to 0.2. Would you bless the stars above you because I see a lovely z-score and you guessed it, that p-value, that 0.44. Hopefully you got a feeling of deja vu as that is at the previous slide. Notice it even gives you a p-hat. I bet you kissed so many stars at this point. If you happen to click the draw feature, this is very helpful for those visual people. Notice you still get the z-score and the p-value, and you can clearly see it's a two-tailed test. It is not equal to. Aren't you all big and fancy? So here's what I'm going to have you do. Go ahead and pause the video here for example 2. This is going to go all the way back to the question we started the lesson with looking at the weighted coin. I want you to try to run a hypothesis test on this, and then go ahead and hit play to see how well you did. Please include conditions to practice. All right, think, show, tell. Think. I put P as the true proportion of coin tosses landing on heads. Not too shabby. Random event. Yes, tossing a coin is a random event. Also because we're assuming the coin is going to be fair. Notice 50-50. Pretty good to go. Potential coin tosses. Show, again, are the mechanics. So null. It is 0.5. When it is not 0.5. This is where I'm going to do both, state the method and the formula. The first one I'm going to do is the method. Notice you only have one sample. You have one proportion. And the best thing is, here's my little p-hat right there above. So this is called a one proportion z-test. Notice that actually matches the selection on the calculator. Here's the z-score in case you're curious. Also, I think it makes your answer a little bit stronger. Here's what it looks like on an updated TI calculator. A little bit prettier, I think. So notice 50-50, 132 out of 220. Proportion, again, not equal to. Here's your calculate screen. Kicked out the z-score. Oh, would you look at the beauty of that p-value? You must list both the z-score and the p-value. This really helps clarify. This will show you how surprised you are because guess what, partner? You just found a very low p-value, which means you got enough evidence to reject the hoe and suspect that perhaps the coin is actually not fair. Again, enough evidence to suggest the coin is unfair. Never claim the coin is unfair because you really only did this 220 times. It's possible you did something wrong, which we'll review in a much later lesson. Here's another you try dealing with American Idol. I'm going to go ahead and pause the video. I want you to pause. When you're ready, please hit play to see how you did. Include conditions. Welcome back to your very last example. Hopefully, parameter you defined is the true proportion of Idol fans who, again, prefer that last performance. It's an interesting question. Random, yes, it says that they were stated a random sample of viewers and videos were even randomly determined or given. Man, they're on fire with their statistical power. Statistical power, if you don't know, is a pun. We'll see that in a later lesson. Number is 600 people. Notice again, 1 out of 12 is what you expect to be true, so make sure you're using that in your conditions. Obviously, population of Idol fans is unfortunately very high. Null, dull, nothing is fishy. Yes, I expect 1 out of 12 people to prefer the last contestant. Hopefully the alternative you did not mess up on because read that question in green. It wants to know, is there an advantage to going last? Do more people prefer the last person? Is the proportion higher than 1 out of 12? Most will miss that step, so be really cautious. Here's that p-hat looking sexier than ever. Go ahead and find your p-value. You know what to do. Here's your z-score, about 1.33. P-value, and notice, is a one tail because all you care about is it being above 1.33. You're not checking two-sided. Well, good to know. Hopefully you have said my p-value was higher than 0.05 and you have failed to reject your null. Don't stop there. Please keep going. Give it some extra zest and add that context. Unfortunately, I have failed to provide the evidence to support or not convincing evidence to conclude there is an advantage to actually going last. Well, good news is that is probably the end of your hand. It's probably all nice and cramped up. And our last example. Please feel free to continue watching more statistical videos to help your knowledge. This has been One Proportional Hypothesis Testing.